you guys there. Um, I will start with an admission. To do anything without metaphysical assumptions is very difficult for any physicist and even any philosopher. A great many things we believe about the world are just assumptions, and we forget that. We take them for facts. So what I'll try to do today is highlight not only the fact that these things we believe, many of them are just assumptions, but that they are also almost certainly false assumptions. And recognizing this opens up new avenues to try and make sense of the so-called paradoxes that we see in foundations of physics. So let me see if this works. I'm having trouble moving to the next slide, but I think this will do. All right. Let's start by looking at the solid ground we do have, the things we do know and are not assumptions. We have perception. That's what we have in order to gather information about the world, even if we use instrumentation, because we need to perceive the output of instrumentation. And perception is eminently qualitative and mental. Another thing we do know is that there clearly is a world beyond our individual minds, an objective world out there, objective from our point of view, in the same sense that even your thoughts are objective from my point of view, even though they are subjective from your own first-person perspective. There is something out there, because if you guys were sitting here in my study with me, you would describe a study that is very consistent with my own experience of my study. So there is something out there outside our individual minds that seems to hold states that are not our internal states. But remember, what physics describes, and André Linde was perhaps the first very well-known reputed physicist to highlight this. What physics describes is perception. It is our apprehension of the world. We describe the way the world presents itself to our observation, not necessarily the way the world is in and of itself. That is fundamentally beyond our ability to access and become acquainted with. So essentially, what we are describing are internal cognitive representations that are modulated by something out there, but they are internal cognitive representations. Physics is a science of perception. It can be more than that, but it is surely a science of perception. So in that sense, the relevant question, as Marcus Miller often puts it, the relevant question is not what the world will do next. The relevant question is, what will I see next? That's what we are trying to predict. We are trying to predict our apprehension, our experience of the world as mediated by the screen of perception. Not only that, but even the notion that there is a non-mental substrate beyond our individual minds is itself a theoretical hypothesis, and an inflationary one at that, because we are cooped up in mental space at all times. Perception is mental. We make this theoretical inference that something that is beyond an individual mind must be beyond mind itself. And if you think about it, it's a completely unnecessary postulate. There can be something beyond my mind that is itself mental, although not my mental activity. So it's an inflationary theoretical hypothesis. Even if you don't agree with the inflationary part, you think it's a necessary hypothesis to make sense of the facts, it is still a theoretical hypothesis and not an empirical given. All right, now from this, we go to what the world is, right? Physics studies the behavior of the world out there, we like to think. So is the world out there the world of perception? In this statement on this slide, I use the word physical, the qualifier physical. Let me be very precise about what I mean by this. The physical world is a world isomorphic to perception, In other words, a world that contains objects with the same boundaries, contours, shapes, and forms, geometrical relationships that appear on the screen of perception. So isomorphic to perception and exhaustively describable through a list of quantities, a list of numbers. The physical world has no inherent qualities, it doesn't have inherent colors, inherent flavors, melodies, scents. No, it is, if you write a long enough list of numbers, you will have said everything there is to say about the physical world. And it is isomorphic with the contours that appear on the screen of perception. This is what I mean by the physical world. And we like to think that the physical world is the world out there in which we are immersed. So if I look out the window of an airplane and I see a storm and lightning and clouds, we tend to think that that is the world as it is in itself. It's not only my cognitive representation of something out there. No, it is that something out there. Those forms are the forms of the world. And that world can be exhaustively characterized by a list of numbers alone. This is a metaphysical assumption, and it is almost certainly wrong because of a number of reasons. I will talk about two of them. One of them, strangely enough, comes from neuroscience, mathematical neuroscience. I'm showing you only one of the relevant papers by Carl Friston, who is a neuroscientist from England. And what these guys try to do is to understand how perception works and what conclusions we can derive from the dynamics of perception. And what they did is they separated the relevant variables in a way that makes the issues visible. So our internal cognitive states belong to a set R. These are our internal states. And the states of the world out there belong to the set psi. Now that they chose the Greek letter psi is very suggestive if you're a physicist. I wonder if they did it on purpose or just by chance. So there is a world out there that contains a set of states, psi, and we have our internal cognitive states, R, and R should represent psi in some way that allows us to navigate the world more or less effectively. Now, these two sets, they do not interact directly. There is a so-called Markov blanket in between, containing two other sets of states, sense states S and active states A. So sense states, you could regard them as the states of your retina, of your eardrums, the surface of your skin, our sense organs. So the world, psi, impinges on sense states S, and then our internal states are modulated by S through this line here. So we know the world only vicariously. We know the world through the intermediation of states S of a Markov blanket that delineates the boundary of the agent we are. In addition to that, we act on the world. So there are active states A, which are also part of the Markov blanket, that impinge on the states psi of the world. It's all very intuitive. Now, one thing to keep in mind is that active states do not require movement. You don't need to move your arms. I mean, your mere existence, the fact that you dislocate air and you occupy a volume in space, that's already an active state that impinges on the states of the world because you exist in the world. So by merely by existing, you impinge on the states psi. Now, what these guys did, and I'm not going to reproduce all this because it's far too complex, and I'm not even sure I still understand it as fluently as I once did. They modeled the dynamics of all these states. and they try to derive some mathematical conclusions about these dynamics based on first principles. It's a complex derivation. First principles come in at different turns of the derivation. It's not something clean, like you start with your premises and then everything else you derive through mathematical theorems. It doesn't go like this. Things are inserted here and there. So it takes quite a while as a reader to convince yourself that the authors are not just pulling a rabbit out of a hat. If you go through that effort, it's rewarding. But what gives me most confidence that this is correct is that the conclusions arrived at from the mathematics are eminently intuitive. If you really understand them, they are almost self-evident. And I try to list them here on the side. Basically, the conclusion is the following. I'll give you the cream of it. You can go through the paper yourself. We like to think that we perceive the world as it really is in itself. In other words, we like to think that the states are mirrors. They mirror the states psi. That perception mirrors the states of the world, one-on-one, within our internal cognitive states. And what they were able to show is that this is incompatible with life. We would not be able to maintain our structural and dynamical integrity if our internal states were to mirror the states of the world. For a very simple reason, there is no a priori upper bound to the dispersion of the states of the world. We cannot say that there is an upper bound to their dispersion, to their entropy. So if we were to mirror those states internally, there would be no upper bound to our internal entropy. Essentially, looking at the world could cause us to dissolve into hot soup. It would be as dangerous as looking at Medusa. So that's not how perception works. Through the mediation of the Markov blanket, what perception does is to create internal states that are encoded inferential representations of hidden states or external states. External states are the hidden states. So the contents of perception are an encoded inferential attempt to gather information about the world without compromising our structural and dynamical integrity. And this is a crucial result because it tells us with a fair degree of confidence, mathematical confidence, if you will, that what we see is not the world as it is. It's an encoded version thereof. Now, this is not the only argument in this line. I will just briefly touch on Don's argument. He has a presentation after mine, but just to put this in the context of my storyline, he comes at the same conclusion from an evolutionary perspective. He says that seeing the world as it actually is would drive us to extinction swiftly. And the way to gather intuition about this is to think of the following. Imagine that you could see the computer files in your computer for what they actually are. In other words, millions of open or closed microscopic switches within silicon chips. Imagine that that's what you saw when you were operating your computer. The computer would become useless. You wouldn't be able to do anything with it. You wouldn't even know which file is what, let alone how to manipulate them, how to use them. And that's why we have the computer desktop, which is a metaphor that shows us the files not as they actually are, but according to a representation that is conducive to action, conducive to survival, if you will. And Don's argument is that our cognitive apparatus, our sense organs, our perceptual apparatus has evolved precisely in the same way. We have a desktop representation of what is really out there, because seeing what's out there for what it actually is would not be functional. It wouldn't allow us to react timely to environmental challenges and navigate the world in order to survive and reproduce. So the conclusion is the following. What we see in perception, in other words, that thing that is supposed to be isomorphic with the physical world, which we even mistake for the physical world, that thing isn't the world. It is a dashboard of dials that convey to us accurate, actionable information about the world. It tells us what is salient about the environment around us in a way that doesn't cause us to dissolve into an entropic soup, and helps us react timely to environmental challenges because of evolution. The problem is we mistake the dashboard for the world. We think the dashboard is the world. To put it in an extended metaphor, we are like airplane pilots who were born within the cockpit of an airplane, and that cockpit has no transparent windows. We don't have transparent windows to see the world as it actually is. Why would we have? Our sense organs are, well, sensors. They make measurements on the world, and they will present to us the results of those measurements in the form that is most compatible with survival. And that form is a dashboard of instruments which has limited entropy. The dials on the dashboard can go to one side and the other, but not beyond. It limits the dispersion of our internal cognitive states, and it allows us to survive more effectively. The problem is because we don't have these windows, we have never seen the world for what it actually is. All we have is the dashboard. So we think the dashboard is the world. That's our dilemma, and that's what causes all the trouble in foundations of physics. This assumption that the physical world is the world as it actually is, as opposed to a representation thereof upon measurement, with or without instrumentation. Now people say, well, but if I use instruments, I can transcend perception. Nonsense, of course not. You still need to perceive the output of the instrument. So whatever instrument you use, your interaction with the world is still mediated entirely through the dashboard. You only see the output of the instrument if it's represented in a dial in the dashboard. You're always cooped up in the dashboard. And all we can do is understand that that's what's going on and guide our thinking based on reason and not metaphysical knee-jerk reactions and assumptions. Now, let's go back to physics and this series of experiments that's been going on since the late 70s, initially around Bell's inequalities, then for the past 19 years around Leggett's inequalities, which are arguably better. I'm highlighting these two papers first because they are based on Leggett's inequalities, and those inequalities have some of them have the advantage of separating realism from locality, so you can test them independently, which you arguably couldn't do with Bell's inequalities. I know all of this is open to discussion. There are opinions of every kind, but hopefully I'm conveying a more or less mainstream idea or interpretation of these things. There is a host more papers. There is the Big Bell experiment of 2018. You know what these are, but just to recapitulate, I know I'm not telling you anything new, but just to frame it in a language that helps me with my story, the essence of the experiment is as such: you produce two elementary subatomic particles together, say photon A and photon B. Because they are produced together, they are entangled. You cannot describe the behavior of one independently of the behavior of the other. Then you shoot them in opposite directions, and on one end you have scientist Alice that makes a measurement on photon A, and scientist Bob on the other side of the universe at the same time makes a measurement of photon B, and it turns out that what Bob sees depends on what Alice chooses to measure. So say if you're measuring angular momentum of a photon, the angle of your polarizer is a choice that Alice can make, and that will correlate 100% with Bob sees on the other side, even though there is no communication possible at subluminal speeds between these two sides. So what this seems to tell us is that the physical properties of physical entities, in other words, the things that characterize those entities, physical entities are a set of physical properties. Those physical properties cannot be said to exist prior to measurement, because otherwise what Bob sees should not depend on what Alice chooses to measure. their measurements should merely disclose what the properties of particles A and B already were immediately prior to measurement in a non-contextual way. But that's not what happens. So we seem to be short of fantasies like many worlds interpretation and superdeterminism, all that stuff. What we seem to be forced to acknowledge is that physical properties do not exist prior to measurement. They are the result of measurement. And not only that, there is this cliche now, this spooky interaction at a distance, because Alice's and Bob's measurements correlate fully, even though there is no communication between them. So we all freak out with this because, you know, if physical properties do not have standalone existence, if they are not there prior to measurement, then what the hell is it that we are measuring? What is the thing measured if it's not the physical thing? Because the physical thing only appears after measurement or upon measurement. And how can these things correlate instantaneously across space-time despite the speed of light limit? Now, I'll seize on this and try to, I'm not going to solve the measurement problem here, but I'm trying to open up a new way to think about it, which makes seeming paradoxes dissolve and everything will seem to be normal. The first one is the ontological status of the world prior to measurement. And this empirical result that physical properties are a result of measurement. How can we make sense of this? Well, let's go back to the airplane's cockpit. If the airplane's sensors are not measuring the sky outside, the world outside, the dials on the dashboard will show nothing. Is this a paradox? Of course not. If you don't measure, there is nothing in the dials. And the physical world is the dials. So if you don't measure, there is no physical world. The problem is that we think the dashboard is the world outside. That's the mistake. We think the dashboard is the thing being measured. It is not. The dashboard is a representation of measurements performed in the world. The world isn't physical insofar as our understanding of the word physical applies to the dashboard and not to the thing measured. Of course, physical properties can only be said to exist upon measurement for exactly the same reason that the dials only show something if the sensors measure the world and nothing until the sensors measure the world. What about the correlations? Yeah, okay, I already spoke through this. So what about the correlations and the spooky action at a distance? There is no such a thing. Here's another way to interpret this. Imagine that you are a soccer fan and you really want to watch a game, but you can't go to the stadium. You cannot be there with the thing in itself, the actual reality, the soccer match in the stadium. So you have to watch it from home, but you are such a fanatical fan of soccer, you buy 2 televisions to watch the same match at the same time. Using 2 different broadcasters. Now imagine that each broadcaster has their own set of cameras in the stadium. So the images in the 2 televisions will be different. But they, of course, will correlate. If in this image, the guy with the yellow soccer is going to the right, the guy with the yellow soccer on the image below will go to the left. Now imagine that there is a time traveler from the 19th century that comes to visit you in your living room while you're watching the match. That guy doesn't see the soccer stadium, doesn't know there is such a thing as a soccer stadium. All he sees are these 2 boxes with little men running in them. And lo and behold, the little men on one box, run around in a way that correlates perfectly with the little man in the other box. Even though they don't communicate across the boxes, there is only empty space across the boxes. My God, what a wonder. How do they know where the other little man is going in the other box? It's amazing, isn't it? Now, what's the mistake? The mistake is that our 19th century time traveler thinks that the images in the televisions are the thing in itself, that the images are the world. And then it's a great mystery how the little man coordinate their movements instantaneously and at a distance without communication. If the the time traveler understood that these are just images, representations of the world, not the world, and that the reality, the thing in itself, is not in the television box, it's not an image, it's the soccer stadium, then there would be no paradox here. Of course, the images are correlated, they are two images of the same reality, but the images are not the reality. The images are dashboard representations of reality. Now, I acknowledge there is one problem still left, which is how come the two sets of cameras, they coordinate their movements? In the context of the metaphor, well, all cameras are following the ball. All the cameras are following the ball. That's why they are coordinated. In the context of quantum physics, yeah, how can Alice's choice of, along which axis to measure angular momentum gets reflected in what Bob sees? What is the ball that is being followed? I don't have an answer for that. But notice that at least we've dissolved a number of paradoxes by understanding that physics is not the thing in itself. The physical world is not the world as it is. It is a television image thereof. It's an appearance thereof, a representation upon measurement in a dashboard of dials that has been given to us by evolution and guarantees an upper limit to our internal entropy. Now, I'll try to formalize this just a little bit, since this is a physics conference. So, well, not yet. So what we have is there are external states of the world as it is in itself. We have no direct access to those states. We will represent them as psi, just like in quantum mechanics. And then we have our internal cognitive states R. And then we have a Markov blanket, the boundary of our agent, surface of our skin, our retinas, eardrums, internal lining of the nose, and surface of the tongue. And this Markov blanket has two sets of states: sensor states or sensory states, which collect information about states psi, and active states, which impinge on states psi. And our cognition comes from these sensor states, and our actions operate on the world through the A states. And of course, S and A can interact with one another. If one of your actions is to turn your head, that will change what your sensory states are, because you're looking in a different direction. There is nothing really polemical about any of this. What we have to understand, though, is that the physical world is the Markov blanket. That's what the physical world is. And of course it is relational, as Rovelli said. I don't even need to explain this further. Obviously it is relational because every observer has its own Markov blanket, which is determined by that observer's perspective into the world. Does that mean that there is no objective world? Of course there is an objective world, psi, but that objective world is not physical. What is it? Well, that's for philosophy. I don't think physicists should go into that. I think the only rational answer to that question is that psi are mental states, just like R are mental states, and physical states are the states in the Markov blanket, which arise from an interaction between two sets of mental states. But for physics, let's not go there. Now, if we ask questions, how can one observer be aware of the existence of another observer in the world? Well, it's very trivial. Let's take this observer here, this guy here. His presence in the world through states A, active states, become quantum mechanically correlated with psi. So psi accrues information about the actions of the first observer in the world. Now, the second observer, this guy here, has states S, which are quantum mechanically correlated with psi. So the internal cognitive states of the second observer can accrue information about the presence of the first observer in the world through the mediation of psi, the states of the actual world out there. And that's why one observer can see the other observer, even though each observer has its own relational physical world. And these physical worlds are immersed in the context of the actual objective world, which is not physical. Okay, now you can say, well, but wait a moment, you're saying that physical states are not fundamental. And you talk about cognitive states as more fundamental than physical states, but we know, don't we, that cognitive states supervene on the physical states of the brain. So they cannot be less fundamental than cognitive states. It's the other way around, right? No, no, this is also an assumption. There is no doubt there is a correlation between brain states and phenomenal states. But, and again, this is trite, correlation doesn't imply causation. I submit to you that the physical states of the brain are what our internal phenomenal states look like from across the Markov blanket. That's all there is to it. And that also explains all the correlations. But let's look at the evidence. Let's look at the evidence to try to sort of understand that this is not only an assumption, but almost certainly a false assumption. Let's look at psychedelics. We have always thought that psychedelics operate by lighting up the brain like a Christmas tree. But since 2012, we have known that psychedelics do precisely the opposite. They only reduce brain activity. You know, the areas in blue that you see here are the areas in which brain activity is reduced upon the administration of a psychedelic substance with respect to a placebo baseline. And this is the case for all psychedelics studied and for all neuroimaging techniques used, MEG, EEG, fMRI, you name it, DMT, psilocin, LSD, you name it, the results are always consistent. This is another study. The previous one was for psilocin or magic mushrooms. This one is for LSD. The previous one was done with fMRI. This one is done with MEG. So you can see here in blue the areas in which brain activity reduces. This is the summary here at the bottom. For the entire spectrum, you can see that placebo always shows higher spectral power than LSD. There is a little region here in which that's not the case, but if you look closely, you see that it's well within the margin of error of the measurements. So psychedelics only reduce brain activity. They don't increase brain activity anywhere. And then it becomes difficult to say, maybe not impossible, but very difficult to say that the phenomenal states of a psychedelic trance supervene on physical brain states, because those physical brain states simply do not have the information required to account for the information in the trance state, the phenomenal states during the trance under physicalist assumptions. And okay, there's a number of papers. This study, these results have been reproduced by multiple groups, multiple labs, multiple countries, multiple substances, multiple measurement systems. You can go through the literature and look at them. Now, of course, physicalists have come up with all kinds of hypotheses to make sense of this. They say, well, activity doesn't increase, but functional coupling between different brain areas increases. And most of these hypotheses have been abandoned because they are just beyond implausible. The one that has been selected as the most plausible is the one I'm going to talk about now. I fished what I think is the key figure of the key paper, and the quantity they came up with that does increase, statistically speaking, upon the administration of psychedelics is what they call diversity, which is just a glorified name for randomness. It's brain noise. It's brain activity patterns that are actually patternless, that do not fit any recognizable pattern. It's like TV static in your brain. Now, it turns out that brain static increases a tiny little bit from, statistically speaking, from placebo to psychedelic administration. How much? Well, an average of 0.005 in a scale from 0 to 100. And that's a statistical result at the very edge of the complexity scale. As you can see here, we are at the edge. These results can never be better. For some of the drug placebo pairs studied, several of them, the correlation is the opposite. So how do you account for the phenomenal states of those psychedelic trances in which complexity or brain noise reduced. But even if it was not for that, I think in any other field of scientific study, somebody looking at these numbers would be forced to say, this is a mirage, there is no result here. This is, it's not even a statistical anomaly. I mean, the threshold of statistical significance was arbitrarily chosen by someone in the 1930s, that this is statistically significant at these magnitudes means precisely nothing. But in the context of our cultural assumptions that we hold very dear, this is the savior of physicalist assumptions. But it's not only psychedelics. If you look further, many kinds of impairment or reduction of normal brain function or brain activity correlate with phenomenal states that are richer, have more complexity, have more information. For instance, this is a study done in, I think it was in Italy, patients that were going to be operated for the removal of brain tumors. They were interviewed and scored for a measure of self-transcendence, ST, which is a measure of how rich your phenomenal inner life is, how much you identify only with your body or with phenomenal states that we associate with the world at large. And after surgery, surgery always causes some, collateral damage in surrounding tissue, so it impairs brain function a little bit. After surgery, consistently, people scored higher in self-transcendence, while controls stayed at statistically the same level. So that's another instance in which an impairment of brain function had the opposite effect in one's phenomenal inner life than what one would expect under physicalist assumptions. There's another one, Vietnam era veterans who suffered brain damage, damaging certain identified areas of the brain correlated with the very rich so-called spiritual experiences, so phenomenally richer experiences than the baseline state of consciousness we have. This is another neuroimaging study done in Brazil. They studied self-identified mediums. I reserve judgment about mediumship, but the study is nonetheless interesting. They had a control group of what they called less experienced mediums. This is just politically correct language. Oh, sorry, politically correct language for people who are not mediums, according to the researchers. So this is the control group, and the experienced mediums. And they asked these people to write down information coming from whatever transcendent source while their brains were being imaged under fMRI. And it turns out that brain activity in areas associated with writing, language processing, increased in the control group for all these different areas of the brain. But for the EXP group, it's consistently decreased for all the same areas of the brain. And to solidify these results, they scored the text written automatically according to a measure of complexity. Computer programs can do that. And the text written by the EXP group scored always higher than the complexity of text written by the control group. So these people were able to write more complex text, although their brain activity level was reduced. I could go on and on, but I'll finish it here. We have to abandon this notion that the physical world, which is isomorphic to perception, is the actual world out there, as opposed to a dashboard representation thereof. We have every reason imaginable to think that the latter is the case. Physicality is an appearance of a deeper layer of nature. It's an appearance, the way that the deeper layer of nature presents itself to us. That deeper reality is by linguistic definition, not physical, because what we call physical quantities are descriptions of the appearance, not of the thing that appears as the physical world. There are many lines of evidence that converge to this. One is the neuroscience of consciousness. The other is foundations of physics that tell us that physical properties and therefore physical entities do not have standalone existence. They are the result of measurement, just like what you see in the dials on an airplane's dashboard are the results of measurements performed by the airplane's sensors. If the sensors measure nothing, then nothing's on the dashboard. If we don't measure anything, then there is no physical world, which doesn't mean that there is no world. Of course, there is a world out there, all right? It's just not physical. Now, I submit to you that level-headed physics shouldn't go into philosophy, should not be based on hidden, unexamined metaphysical assumptions. We should not assume that the actual world out there, as it is in itself, is physical. We have no reason to make that assumption. We have no reason to assume that physical entities have standalone reality because experiments are telling us they are the result of measurement. And we have no reason to think that physicality is ontologically distinct from mentality. It's a completely arbitrary differentiation because physicality, again, is a conceptualization based on what appears on the screen of perception. And this screen of perception is mental. It's a cognitive representation of the world out there. If we understand all this, we will have much more promising avenues for making sense of the so-called paradoxes in foundations of physics. And I will wrap it up here. And if we have time for questions, I don't know, I didn't control my time.
Right, thank you, Bernardo. Questions? Go on.
I think I am a Japanese doctor, so my doctor's perspective, I am very different impression for your expression. So because the human being is not machine but creature, so we have to the vital sign or vitality is not material but distinct. And for example, in inner you said that the inner cognition and outer is the outer and brain feels outer from cognition. But for example, abdominal pain or headache, almost all people feel abdominal pain or gut feeling or headache. Which is the inner or outer? That is the clearly this you cannot clearly distinct that two. So I think that the human being is a creature, not machine. Your theory is the human being is only machine, so we can analyze more and more in detail as a machine. That is not true, I think so.
I agree. It's not my premise that human beings are machines or mechanisms. I tried to speak in as general terms as I could. The question of whether we are mechanisms or not relates to whether we can be fully modeled as formal systems or not. I think the answer to that question is not there. We don't know the answer for that question yet. But even as organisms, we clearly observe the world. And when I talked about measurement, you should interpret that in the case of human beings as an observation. So it's just word usage. I try to stick to the common word usage in physics, which I think is more rigorous and less ambiguous than other words. But that was the only reason I used that vocabulary. I didn't mean to imply that human beings are mechanisms or formal systems. They may not be. Now, when I talked about brain activity being the outer appearance of our inner cognitive states, which are phenomenal in essence, what I meant by that is that brain activity is something physical. It's part of the physical world. It can be discerned in the screen of perception when a neuroscientist looks at the output of a brain scanner. As such, brain activity is a representation on the dashboard. It is not the thing in itself. It's a dashboard representation. Of what? Well, of our inner cognitive states. What else? We know they correlate with our inner cognitive states. If the physical world is an appearance of something, then it ought to be an appearance of our inner cognitive states when those are displayed or represented upon measurement on the dashboard of dials, that dashboard being the physical world.
Okay, next question from Don. I have a question about the entropic argument that you gave. One could perhaps argue that, yeah, you don't want to have the entropy of the internal representation match the external. You dissolve. But perhaps if you still want to maintain some kind of realism, you could say, look, you could have a projection, a faithful projection of the entropy on the outside to whatever entropy you have on the inside. And so as long as there was a faithful projection, then we would therefore be able to say that, you know, in some sense we're seeing reality. So how would you deal with that objection?
Well, I don't see a problem with that. That projection, in order for it to have bound entropy, an upper limit to entropy, would have to be part of a scale that is limited on both ends. Think of it as the edges of a needle dial. That needle cannot go beyond a certain limit. You know, anything beyond that is the same from our perspective. Now, if wind speed is above 1,000 kilometers per hour, you don't need to measure anymore. You're going to crash your plane. So it is the paradigm of the dashboard that limits entropy. Now, this is not to say that the dashboard isn't accurate. It's eminently accurate. It picks out what is salient about the world to enable us to fly this airplane we call life by instruments alone, safely, and land safely. Dashboards are very accurate, and dashboard could be interpreted as a entropy limited projection of the salient aspects of the world outside. None of this means that the world looks like the dashboard. The storm outside the airplane's window doesn't look at all like the dials on the dashboard. There is no isomorphism. There is, of course, a correspondence that allows us to talk of the dashboard as conveying relevant and accurate information about the world. But that correspondence is non-linear, and it does not entail isomorphism at all. What we describe with physical quantities are the positions of the needles inside the dials of the dashboard, not the world as it actually is, which we have every reason to think as non-physical.
We'll pursue it just a little bit more. So instead of isomorphism, suppose we're just asking about homomorphism. So I'm a physicalist, and I say, of course, I don't believe there's an isomorphism, but all I need is that there's a homomorphism between the structures of objective reality and the structures that I perceive. And that's the sense in which I say truly. I don't see exhaustively, but I see truly. So to say that I don't see at all, you'd have to say that there's no homomorphism. How would you deal with that kind of argument?
Well, homomorphism means that there is some sameness relationship. I would describe this as accuracy. There is a sameness relationship in the sense that something about the position of the needle in your airspeed indication is the same as something about the air flowing outside. Sure, there's certainly no doubt about that, but I don't think that in any way provides an argument for physicalism or releases the pressure of the argument against physicalism, because it only means that the indications in the dials, if interpreted correctly, do say something true about the world. But amongst the things that may be true about the world is not the physicality of the world, because physicality is the paradigm of the dashboard. It's not applicable to the world. It's the way, and you would talk next to me about space-time, Don. Space-time are the extensions of the dashboard. They are the dimensions that the dials use. There is no reason to think that space-time are the actual dimensions of the world that is measured. They are part of the paradigm of measurement, post-measurement paradigm, which is grounded in our cognitive apparatus in the way we cognize the world, as evolution has built us to do. So I wouldn't say that a relationship of sameness in some sense in any way stops the refutation of physicalism based on this argument. At least I don't see how that could be the case.
Bernardo, we'll finish very soon. I'll just put a really quick question in before we end. So the psychedelic stuff, it sounded like you were using this to suggest, look, physicalism must be true. It can't be that the mind supervenes on the brain, because then you've got this great intensity and experience that does not have a corresponding intensity in brain activity. I was a bit puzzled by that argument, because if I take psychedelics, I'm not surprised that my brain activity goes down. Yes, I have a more intense experience, but then all kinds of other things, my ability to remember what's happening, my ability to respond in a coherent way, all this other stuff lessens. So you might think that your results support physicalism as opposed to oppose them.
Obviously, you have never had a high dose psychedelic trip, because if you had, you wouldn't be talking this way. Okay, I'm not going to appeal to my personal experience because I don't think it's valid. I will point you to studies done at Johns Hopkins University about the richness and intensity and personal significance of psychedelic experiences. What you have to keep in mind is that you cannot exclude certain aspects of the experience as not needing a physical correlate under physicalism. For instance, some people say, well, it's just the meaningfulness of the experience that has increased. It's not the number of colors or the variety of sounds. It doesn't matter. Under physicalism, the meaningfulness of the experience has to have a physical ground. That meaningfulness has to correlate with something in brain activity. If meaningfulness increases to the point that you consider a psychedelic experience one of the three most meaningful of your life, right next to the death of a parent or the birth of a child, something spectacular has to be going on in your brain, because the experience of meaningfulness is not nothing. It is something. It's a phenomenal state. The way now I'm going to talk very briefly about philosophy. The distinction between the physicalist assumption and the metaphysically neutral assumption is the following. Under physicalism, phenomenal states supervene on physical states. So the entirety of the information in the phenomenal states has to be grounded in information in the physical states. And that seems to not be the case for a certain set of circumstances, like psychedelics, certain types of meditation, brain injury, surgery, and so forth, or the choking game, asphyxiation. Well, anyway. But under a metaphysically neutral or maybe an idealist view of the world, if you understand that physical brain activity is a representation on the dashboard of cognitive phenomenal states. In other words, brain activity is what cognitive states look like from across the Markov blanket. They are an image of the cognitive states. If you understand it this way, then images do not need to be exhaustive. They do not need to be complete. Images can be partial. Images don't need to say everything there is to say about the thing they are an image of. But causes need to be complete. An effect should be fully accounted for in terms of all of its causes. There cannot be anything to the effect that you can't find back on its causes. Images are not like that. Images do not need to be complete. And that's what sort of dissolves some of the paradoxes again, even in the neuroscience of consciousness, not only in foundations of physics, I think.